Hello, in this tutorial we will go through different kind of problems that can be solved under the concepts of virtual work. Just a recall of the kind of problems that we did in the previous tutorials, the kind of problems that we understood in our previous tutorials. The first one included finding the resultant of concurrent force system. In that, we first assumed an equilibrium E in the first quadrant so that its horizontal component will be positive and its vertical component will also be positive. And we found the magnitude of E cos theta and E sin theta by summing up the components of all other forces making a system. And we got the consolidated value of minus E cos theta and minus E sin theta. Then we equated R cos theta to minus E cos theta and R sin theta to minus E sin theta, R being the resultant of the system, which is just equal and opposite in sign when compared with the equilibrium, and resultant and equilibrium are mutually opposite but equal in magnitude. We made use of this particular knowledge in order to solve the problem. Then we found the magnitude and direction of the resultant by telling R equal to square root of R square cos square theta plus R square sin square theta, and sin square theta and cos square theta adding up becomes 1, and we would have got R. And we also found the direction of the resultant by just finding the ratio of R sin theta divided by R cos theta, and we appropriated the values that were gotten in the previous step, and we got the direction of the resultant also. The second kind of problems we looked into in the tutorial number 3 happened to be finding support reactions, and there we gave a positive virtual displacement of del y for the support in positive upward direction or positive rightward direction, as the case may be. Right, we gave a positive virtual displacement of del y for the support in positive upward direction or positive rightward direction. Once again, of course, it is repeated. Find the relative virtual displacement at the other points of loading. We did this by comparing similar triangles, and we made, let us say, del y d at point D to be a fraction of del y. And we had only one kind of virtual displacement at all locations as a multiple of del y or as a function of del y, and we found the total work done by all the forces, and we equated to 0, and interestingly it happened to be solution to the problem. We got RA, RB vertically upwards and vertically downwards, and as the case may be, right? And thus in this tutorial we are tackling a different kind of problem altogether, which are very similar to the friction problems that we saw in the previous tutorials. This is the 8th problem, cumulatively numbered. Find the magnitude of the force P consistent with equilibrium. Consider the flow to be smooth. Assume coefficient of friction equal to 0. And if that is the case, it cannot be smooth, since the value of the frictional coefficient is given, and we cannot consider the flow to be smooth. I think we thought of doing this kind of a problem. It becomes very primitive, therefore we have just avoided this. Yeah, and this is the problem, and here is the force P that is being applied. We need to find this force P, considering that due to P this will start moving, but anyway the system is in equilibrium by virtue of the normal reaction and the frictional force acting like this. Therefore, in total, in its entirety, the system is in equilibrium. It doesn't move to the right as is expected. Therefore, we will offer a small virtual displacement of del x in positive x direction, so that the new location of this particular block will be to the right, owing to the virtual displacement of del x in rightward direction. Now we resolve sigma fy equal to 0 here we are not applying any principle of virtual work. It is with the sole purpose of finding what n is what n is, therefore what frictional force is, which is equal to 0.3 n according to Coulomb's law. Therefore n minus 1000, n is going vertically up, minus 1000 is the weight coming down, which is equal to 0. Therefore n will be 1000 Newton. Now upon finding n, this will become 300 because it is 0.3 into n. Now work done by forces in moving through the virtual displacement equal to 0. Therefore P is acting like this, which is positive, del x is also positive. Therefore work done by P is, we will make it as anyway, yeah, work done by P is positive because P is also positive, del S is also positive, and therefore P into del S is positive work, minus 0.3 because the force is going in this direction. Force becomes negative, but the displacement is positive. So 0.3 into 1000 into del S equal to 0. Therefore P equal to 300 Newton. And we would have got the similar answer had we done this problem using the principle of equilibrium, wherein we must have equated sigma fx equal to 0 after finding sigma the value of the n and the frictional force. The ninth problem comes like this. Determine the horizontal force P required to hold 2000 Newton block in equilibrium over a smooth inclined plane. And here there is no, since the inclined plane is very smooth, there is no question of any frictional reaction frictional force. We will assume a small virtual displacement along the plane and across the plane in positive directions. Of course, as far as this problem is concerned, since we need not have to establish the value of n, there is no need to give virtual displacement in vertical direction. Okay, and had we asked about to find the n, we would have given the virtual displacement in vertical direction also. Anyway, we will carry on with the solving of this problem by just giving a virtual displacement along the plane. So along the plane means like this, which is positive. So del x given over here along the plane, because the plane itself will become x-axis. Even in any case of a problem, in any problem related to inclined plane and finding reactions, and we have assumed, we should remember that we should assume the inclined plane itself to be x-axis and a line perpendicular to the inclined plane to be y-axis. Y-axis. Therefore, this is the displacement given along the incline rightwards. Therefore, this virtual displacement is positive. Let us see. Since the block is in equilibrium, work done, sum of the algebraic sum of the work done along the incline to be equal to 0. Therefore, the component of 2000 in the along the incline, which acts like this, downwards 200 sin 30, 2000 sin 30, which acts like this, is negative by its nature because leftward forces are negative, and P cos 30 is positive. So P cos 30 will does a positive work because it moves through positive distance. Positive force moves through positive distance, and this is a negative force which will have a tendency and which has to move in this vertical, in this direction. Therefore, as far as movement is concerned, it is positive. Displacement is concerned, it is positive. The force itself is negative. So let us see that. So P cos 30 into del x, which is positive, minus 2000 sin 30. So minus 2000 sin 30 is the horizontal component of 2000 into del x. Del x is positive. Therefore, and when you simplify this, we will get del x out as a common factor, del x cannot be equal to 0 because we have only given the virtual displacement under the ambit of principle of virtual work. Therefore it cannot be 0. Therefore the thing within the bracket, the expression within the bracket must be equal to 0. So when we resolve this, when we simplify this, we will get the value of P to be equal to 1154.7 Newton. Had we asked to find out N, we would have applied algebraic sum of work done by forces across the inclined plane to be 0, and we would have assumed a small virtual displacement up perpendicular to the incline, and it would have resolved all the forces vertically, that is perpendicular to the plane, and giving due consideration for the positivity of the force and their component. We would have computed the sum of the work done like this, and we would have equated to 0, and we would have found N. Now 10th problem goes like this. For the smooth inclined plane, determine the range of weight values of block A to keep the system in equilibrium. So it's something like this. The problem is something like this. So block A is this is the weight. So if the weight is more, the block will try to move like this. So that is one value of W. And if the weight value is less when compared to this 1000 Newton, the block will start moving like this. So in the former case, weight will have a huge value, and in the latter case, weight will have a low value, because this 1000 Newton block outsmarts the weight of this particular block, and it will be effective in pulling the block A in upward direction. But anyway, we will consider both the cases of being W, the block A moving downwards and block W moving upwards by giving virtual displacement. For any situation, we will assume the system to be in equilibrium, and it is showing some kind of an impending motion. It is at the verge of motion. That is the state of equilibrium as far as these kind of problems are concerned. Now, tendency of block A to move downward the incline by del S. We will just take this. This is del S, and here we should look into the fact that del S is negative as far as our sign convention is concerned, because this will become x-axis as far as this block is concerned, and this will become x-axis as far as this block is concerned. Therefore, for both the blocks, del S happens to be negative, and we will see how exactly we need to. And this tension need not be considered separately, because under the problems under virtual work, we don't need the free body diagram, exclusive free body diagrams. There is a tension which is common here. It is, let us say, T going rightwards, T going in this particular plane. Therefore it is not needed anyway, and the system is pulled in its entirety. When this is pulled by ds in downward direction, this will rise up in the upward direction, right? So we will find out the work done when this block moves through a negative distance of del S along the plane. And this will also move to an extent of del S, and this becomes leftwards as far as this inclined plane is concerned. Therefore del S here is again negative as far as 1000 Newton block is concerned. So minus sine 45, W minus W sine 45, and this is W. Its component goes like this down the inclined plane, and if this is considered as an x-axis, it becomes leftwards. Therefore W sine 45 becomes negative, and minus del S, this is also negative. This is purely out of our sign convention, that's all. Therefore this is W does a positive work. The component of W does a positive work. In a real sense also, W sine 45 is acting downwards, and the block is also moving downwards along the incline, and naturally it is a positive work. But anyway, according to our sign convention, it's again becoming positive work, because double negative makes it positive. 1000 sine 60, this one 1000 sine 60 is going like this. The component 1000 sine 60 is going like this. 60 is referred with respect to the vertical. This is y-axis, and 1000 sine 60 as far as this inclined plane is concerned becomes rightwards. rightwards, and because this is the x-axis, this is leftwards, this is rightwards. Here we should notice that the force, the component of the weight along the incline is positive, but del S is negative, because del S is moving leftwards, and here also leftwards. Leftward is negative, and here also it is leftwards, it is del S. It is the same amount. If this is pulled by del S, this will rise up by del S, and this rise happens to be leftwards when we consider this inclined plane to be x-axis. So n1 into 0, this is n1, this is n1. N1 will not do any work. N1 will not do any work. Let us say this is n1. So also n2. This is n2. N2 and n1 doesn't do any work, because the movement del S, either leftwards or rightwards, is inconsequential as far as n1 and n2 is concerned. But anyway, for the sake of clarity, for the sake of completeness, we need to include them. So W in this case, when the block moves downwards, will be 1294.25 Newton. Let us see what happens if the block rises up, or this block makes this particular block to rise down, move down. Yeah. Oh, that is not the range anyway. We found only one kind of work. Okay, I think determine the range of weight values. Okay, if this were to be the question, once again we have moved it downwards. Anyway, this question is not answered properly, that is completely, and our respective viewers can definitely try this. You just provide a displacement of del S in this direction, then W10 1000 sine 60 does a positive work, and here W sine 45 is negative, but it does a positive movement. So minus W sine 45 into del S equal to plus 1000 sine 45 into del S. Sine 60 into del S, and that will give us a value of W which will be less than 1294.25. anyway, similar kind of point culminate in problem number 11. Let us see. A block that weighs 1000 Newton is to be held in an inclined plane as shown. For what range of P it can be held in equilibrium? Take coefficient of friction to be 0.3. This is very much similar to the previous problem, but we have only one block over here. We should be treated independently, and if we make a cut over here, this wire that is being taken over the pulley will experience a tension of P. Tension of P will prevail everywhere on this wire. So we need to look into two cases again, when the impending moment is up the plane and the moment is down the plane. So we will consider movement up the plane. Let us give a virtual displacement of del S up the plane and along the plane. So this is the plane, and we have given del S, del S vertically up. So now we should say that del S is positive. As far as displacement is considered, it is positive. It is showing a tendency to move up. Therefore, there is a frictional force which is coming down 0.3 times n, and here is the normal reaction. This is the weight 1000 Newton which is acting vertically down. Therefore, this angle is equal to 70 degree. The angle between the vertical to the incline and the weight should be 70 degree. Yeah, it's here. It's marked. So no issues. Right, now we will resolve the forces. In order to find the value of n, we need to resolve the forces perpendicular to the incline. We will find 1000 cos 70, 1000 cos 70, which is going down. Okay, should be equal to n. N is positive and this is negative. We will get a value of n to be equal to 342.02 Newton, and therefore we will find P into del S, P going up in the rightward direction as far as this x-axis is concerned, which is inclined at an angle of 70 into del S. So this is the positive work, positive force and positive displacement, and minus 0.3 into 342.02, this is the force which is negative, which is going down, that is leftwards, into del S. Del S is positive anyway. minus 1000 sine 70. This is 1000 Newton, the weight, and this is the vertical to the incline, and when we resolve the forces across the plane, this will become 1000 sine 70, which is going downwards, that is leftwards. Therefore here the force component is negative, but the displacement is positive. Therefore, and when we simplify this, we will get a value of P equal to 1042.3 Newton, which should be definitely high, because this is to be pushed up against its gravity, that is its weight. Therefore naturally it consumes more P. Now we'll take the second case, movement down the plane, and here is the free body diagram, and here it is trying to move down, and there is a frictional force, which is, in the previous case it was up, the frictional force was down, and here it is down, the frictional force is up, and all the other forces are there in tantrum, and this is the direction of the movement that we are giving, which is negative. Now in the second case, the displacement is negative, because if the inclined plane is taken as x-axis, this becomes leftwards. Now let us give a virtual displacement del S down the plane. Actually should be down the plane. Should be down the plane. Yeah, we will make it, should be down the plane, sorry. Down the plane, which happens to be automatically negative according to our sign convention. Yeah. Now we have to find the value of n. We will resolve the forces perpendicular to the inclined plane. We will get n equal to 342.02 as earlier, and now P is positive, del S is negative. Therefore P into minus del S, and as far as this is concerned, force is positive, del S is negative. And as far as the horizontal component of this weight is concerned, it is acting downwards like this. It is 1000 sine 70, which is acting downwards, that is negative, and this is also negative. So negative force component, weight component, and negative displacement makes this particular work done by the component of the weight to be positive naturally. So now with this arrangement, with this kind of movement, P will become 837.1, which is really less. It requires a less amount of force, because naturally the bodies will move down the inclined plane without any effort. And here there is a wire which is holding this, therefore it requires some effort, which should be against P. And here, since the movement is down the plane, naturally we need a small amount of force to hold this in equilibrium. Therefore possible range of P is 837.1 Newton and 1042.3 Newton. When the block will be moving downwards direction, or tendency to move in downward direction and tendency to move in upward directions. With this we will complete the kind of problems that can be tackled under virtual work. But however, certain problems still remain, which are much complicated, and they deal with the connected components and connected systems, connected articulations, and complex structures and complex structural actions, complex mechanisms. Of course, that doesn't come under our purview, so we will stop here discussing virtual work, and the next tutorial will be on moment of inertia and centroid. Until then, bye. And if you have not subscribed to my channel, kindly subscribe to my channel.